Well, hello again, friends, and everyone out in YouTube land. This is what I hope to be the final part video for this Harris RF-2601 antenna coupler. And we're going to, last we met, I had done a bunch of wiring up from this controller here. And as you can see here, I used two Ethernet, two Cat5 cables, plus the third black one here is power. And I've got them going to two other cables using these RJ45 pass-throughs or bulkhead pass-throughs. These bulkhead pass-throughs will eventually be mounted on one of these 1U rack panels, and this 1U rack panel will be mounted in whatever enclosure I end up using for the 2602 status monitor, and it'll be on the back of the enclosure. And then between this and the transmitter, all I need is a pair of Cat5 cables, and we're all good and done. So in this video, we're going to wire it all up. We're going to turn on the Harris transmitter, connect it up, and see if it works. Yeah, just before we start everything up, I wanted to go over one new component to the system here. And this came from a friend of mine, KI6KYK, out in California, is another Harris collector. And this is an adapter. As you can see, we added it on these two screws. It is a long wire adapter. What exactly is a long wire adapter? Well, let's see if I can get a little more light on it. It is to allow the coupler to work with electrically a little longer antennas than it's designed for. So typically, this is designed for use on shipboard, and the typical vertical on a ship is a 35-foot vertical. And if you want to use these with wires, long wires, for example, that are longer than 35 feet, which most long wires are, you need this adapter. Or what this adapter does really is, as you can see here, it connects up, goes through a standoff. Inside, and I'll show pictures of the inside. Inside of this is a 150 picofarad capacitor to electrically shorten whatever antenna that you put in it to allow the coupler to have a better success at matching it. Now, the one thing that we did do differently is, and again, my friend helped with this, is instead of having another standoff, high voltage standoff, which is how these are normally constructed for the long wire, he adapted this for a coax and end connector. Most likely, whether this is going to be used for a dipole or something else, I don't know, but it just gives me the flexibility to do that. Okay, so let's get started with our testing. Okay, just to review. So as I mentioned before, we've got these two yellow and blue cables, and you can see I've got them going to a gray Cat5, and then this sort of flat one I happen to have in the shack that reached over, and I'll show you where these go to. And so these go to the back of the transmitter, and I'll show you the back. All right, and so here's the back, and you should hopefully recall from the last video we made this bottom panel here. Hopefully it will actually focus. And the bottom panel has, again, the gray that I showed, and this is that flat connector, flat cable that I have going over. So, and I just marked them yellow and blue. I mean, it's just really any designation will work to keep it connected straight. Even though they're not yellow and blue, it could be 1 and 2 or whatever. And again, that's in the back of the transmitter. All right, so the next thing we have to do. The next thing we have to do is we're going to pull out the exciter and set it up for use with a coupler. Okay, so here's a picture of the exciter being pulled out of the amplifier. It's on slide rails, which makes it very convenient. And also these rails have tilt mechanisms in them, so if you need to work on the front or the back or something, it makes it easier. And then the next picture here, we removed the top of the exciter, and now it's time to look inside. Inside the exciter is a module called the A18A1. This is the system interface assembly. There are two system interface assemblies, A1 and A2. This is A1. Luckily, it's the one that's much more visible. And you can see here that there are 4 dip switches. And the one we're most concerned with is number 3. This is all switch 1. These 4 represent switch 1. And we're interested in number 3, which is coupler control. There are several places that talk about the function of this switch, and they are very confusing. Let me show you what I mean. Okay, so what we have here is a manual, page of the manual from the transmitter itself. This is the a manual from the 1140A transmitter documentation. And this gives you all the details of what these 4 dip switches do: transmitter gain control, attenuation control, signal generator mode, and this is of course the one that we're most interested in, coupler control. So again, this is from the transmitter itself, and what it says here is if the switch is closed, it means that there is no coupler attached, and if the switch is open, it says that the coupler is attached. So, okay, fine, I'm attaching a coupler. One might think that I ought to set this to open. And it says here that the coupler operates if the switch is closed. However, there is no coupler tune fault timeout with the S13 switch closed. This fault is displayed on both the exciter and the PA front panel. So, a little confusing, but let's take a look at another version of this page. And let's see, I think it's up here. Okay, so this, even though it looks like it's in the same PDF, it's actually not. I put this together. So this is a page out of the installation manual for the 2601 itself. Okay, so again, it looks very similar. Now let's see what it says. Again, coupler control tells the exciter to include an RF-601A antenna coupler in the tune cycle. Position switch closed for a RF-2601 antenna coupler. Closed is all couplers but the 601A, and open is the 601A enables a timer. So it is a little confusing, but I'm going to set it to closed based on this comment right here within the version of this table designed specifically for the 2601 antenna coupler. All right, let's give this a test. So I'm going to turn this on. Maybe you heard the coupler power up. And I also want to point out how I've got these switches. So this is a page from the manual from the antenna coupler. And what it does is it gives you an outline for various kinds of transmitters, how you set these switches. Now, even though it shows, S3 is first and S1 is second, and that's exactly how this is, S3 and S1. And if you can see here, if it'll focus, I've got, let's take a look here. My actual transmitter is not listed here. Mine's an RF-1140, but this looks pretty close, 1130, so I'm going to go with this one, which has everything open except S14 is closed. I mean, it's just the best information I have. 1140, 1130, they're kind of in the similar era, anyway, of radios. So let's take a look. And I've got open, except S14. Focusing is quite difficult. S14 is the only one that's closed. All right, so let's test it. This is on. This says ready to go, and let's test it out. All right, so let's power this on and see how it works. All right, we're powered up. You saw earlier that the coupler is powered up. Let's put it in standby mode. We just have a random frequency in here of 12 megahertz. Put it in standby mode. Now let's put it in operate mode. Here you'll get some fan noise. Okay, and as you can see here, we've got the tune light on. So let's give it a tune, see what happens. Fingers crossed. Uh-oh. That's not good. Alright, what do we got here? We have fault 2A05. Got a fault light on. And let's see if I can do this with the tripod. It's still attached. And what does this say here? Very hard to read it at this angle, but it says fault 2A05. Coupler tune failed. All right, well, let's go see. Let's try it again, actually. Let's first try it again, see if anything changes. Let's try it one more time, just in case it needs to get warmed up somehow. Still a fault. Okay, the fault cleared. Let's see, can we do this any better? It's down here. It says, I don't know if you can see, it says normal operation. I don't know if that's at all visible. Probably not. And let's try it one more time. Tune. No. Same exact problem. Same problem. Fault 2A05 and coupler tune failed. All right, well, let's walk over to the coupler. Let's see what we see there. All right, well, we have some LEDs on here. So clearly we've got the main fault LED is on. And we've got this bypass. Even though the bypass switch is off, I think when there's a fault, it automatically goes into bypass so that at least you can receive, if you're using a half duplex setup, you could at least do some receiving on the system, is my understanding. Fault, and then we've got the status light. So let's see if we can count what we have here. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay, so it looks like a 3, 4. I know that it's the lower number is first, the fewer numbers first. And so what do we got here? I'll also mention that this card, again, this is the card that comes with the system, also has this exact same table. So 3, 4. Okay, so what I see here is the test status LED flashing is 3, 4. Pressure fault. Check coupler pressure. Okay, well, all right, maybe that's it. That could be very logical, but I'm not exactly sure if this is the continuous surveillance test or a static test, because on the static test, 3, 4 says frequency counter, like an error in the frequency counter. Check these modules, A3, A4, A9. So I'm not exactly 100% sure. Now, look, we know that there's no pressure that there's no pressure in the coupler, 0. And so, you might think it is that. The only thing I'm thinking though is that even with 0 pressure, the coupler worked fine when we connected it to a non-Harris radio. This Sun Air actually was what we used. And so why would it work with a non-Harris radio but fail on a Harris radio? I'm not exactly sure. So I think one thing I'm going to do is I'm going to look into the switches and the setup. I'm not exactly convinced that I have the setup right. I get a sneaking suspicion that this thing's going to work, and that if I have the configurations all set up right, that it should work. So let's take a look at it. All right, I wanted to do one other test, which is to control the initiation of a tune cycle. Instead of doing it from the transmitter, the exciter, which we showed earlier, I want to initiate it from this from the status monitor here, and we can look on this SWR and power meter. This is connected to the input of the coupler, and then the output of the coupler goes to the dummy load, and actually goes to another power meter, and then a dummy load. But let's take a look at this. So the way to initiate a tune cycle is, let me see, maybe I ought to turn this off. Maybe that'll be clearer. I'm not sure. Is you click retune, and then you press this key, and it should initiate it. So this, I'm going to press that, and let's watch here. Okay, so something was happening. You could see that the power, I should say I had this on 2000, maybe I ought to lower this to 200. But at the 2000 setting, it looked like it was 2000 is the top setting. Look, about 100 or so watts. And the SWR was was fluttering around looking for a solution. Let me go back over the transmitter, and you can hear probably it shut down. Let me start it back up. Okay, so I got it started back up, and we're going to do it again. Just want to see, let's observe exactly what's going on here. Here we go. SWR. See, SWR was low when it kicked off. It was low. It wasn't even above 1.5. So why would it kick off with a nice 1.5 low SWR? You'd think it wouldn't fail. And of course, again, here we have the fault line, the fault light, and then the status. So not exactly. It almost seems like the transmitter is not giving the coupler enough time to thoroughly get a solution and lock it in. It almost looks like maybe this fault here is triggering the exciter, triggering the transmitter to cease operation and no longer, and stop the whole cycle. Let's look into this a little more. So let's review again the signals. And they happen to be split into a yellow cable and a blue cable, but these are all the signals I'm looking for. And what am I looking for? I'm trying to see which of these signals could be responsible for telling the transmitter to shut down, and therefore maybe not giving enough time to the coupler to find a perfect solution or the best solution. And so, let's look at these. We've got fault, clearly. Key disable, I think that's one that could do it. Number 10 here is a temperature or pressure fault, and we'll look into that as well. Coupler start test status, coupler, and fault override. No, I don't think that's it. So I think the only ones really are fault, key disable, and this temperature pressure fault, which I assume only follows when there's a fault line. So what I think I'm going to do is let's now take a look at the diagram, and let's see if we can't learn a little bit more about how all this works. Okay, so here is the diagram of the status monitor, and something very interesting has occurred to me here. So these are the switches. This is S3, even though on the circuit board it's the one on the left, and here's S1, and on the circuit board it's the one on the right. But very interesting. So let's take a look at this. So what you have here is signals from the transmitter and to the antenna coupler. And you'll notice here that there are many signals that transfer directly over, and then there are some signals here that first, before they get transferred over, they come down through these dip switches and then slide over. They find their way into various other circuitry, but all of them also then find their way to the antenna coupler. And what's interesting is the settings that I've been using have all of them open except this one. You see the little red line I added here. This is the only one that using for the 1130, the RF-1130 transmitter, this is the only one that's closed. All the rest of these are open. And so let's take a look at what all the rest of these are. So the closed one is bypass, and that's a command from the status monitor to the transmitter. Here's the transmitter, telling the transmitter that it's in that you forced it into bypass mode. That's the only one that's connected. Let's look at all the ones that are blocked, essentially, not connected. This one is coupler fault. Well, so coupler fault is not even making its way from the antenna coupler to the transmitter because, again, it's an open circuit. The next one here is over temperature fault. That's not making its way through. This one is a test. Okay, that's not making it through. That sounds fine, though. This one is test status is not making it through. This one is coupler ready. Now, that is surprising to me. We don't even have a signal coming from the coupler to the transmitter telling the transmitter the coupler is ready. Again, because the diagram we're using has all of these open. And then finally, the last one here is fault override. So, yeah, very bizarre. Very, very strange. Let's see. There was the other one was, what was the other one? Key disable. Did I miss? Oh, so actually, key disable does go automatically through. There's no way to block it using the dip switches. Key disable. In my simplistic way of looking at this, key disable must be the signal that's coming from the coupler to the transmitter and stopping the transmitter from allowing the coupler to continue working. So what I'm going to do here is I'm going to, well, I'll show you what I'm going to do. Okay, so this is what we're doing next. I'm using this little breakout board that I got from Amazon from a company called Winford Engineering, Winford.com, which is just a little breakout box that allows you to split the cable and put the RJ45s in each one, and then control here which signals pass through, which do not, and it has also headers so you can pull the signals off, cross them over, or check them with a voltmeter, whatever you need to do. Very handy little device. I definitely recommend this and other things in this company. So what is it that we're trying to accomplish here? So going back to a wiring diagram, you'll pardon the crossouts. It ends up that because of these dip switches all being essentially open, all this effort that I put into making this blue cable is wasted. None of these signals are moving from the coupler, between the coupler and the transmitter at all. They're all open circuit. And most of these are not either. In fact, they're only the only one is this key disable. So we're going to see if this key disable is the thing that's shutting down the transmitter. And then if we interrupt that signal, if we can maybe give the coupler more time to get a complete tune cycle in and maybe work. So this is the one we're going to disrupt. On the RJ45, it is represented by pin 7. And so let's disable, break up pin 7. Okay. So here, shield 8, here's pin 7. We're going to move that to open. Okay, so all the other ones are proceeding forward, and this one is not. So hopefully, the coupler will not tell the transmitter to stop its tune cycle. All right, if you could hear, maybe you can hear it, but the transmitter is up and running and in operate mode. And so let's go ahead and try it again, and let's take a look at here. Okay, what happened? Well, okay. Listen, we learned something here. We still have a fault, but if you can hear the fans, the transmitter did not shut down. In fact, we should be able to initiate another tune cycle right from here. We hit retune, which clears the fault. We hit key. And again, still a fault. One last time for shits and giggles. Clear it. Strange. Again, it seems to have a low SWR, but look, Now that there are no signals being causing the transmitter to shut down, the transmitter is staying operational, but I still have this fault. So now I'm thinking that the fault really must lie with the coupler. All right, let's go to the next stage of this troubleshooting. All right, so I decided to go do some research in the manuals, and there are all kinds of manuals involved in this system. And it's been a couple hours actually since the last part of the video, but I came across this mention. So I'm looking at all the manuals, any mention of antenna coupler, and this is a page from the power amplifier manual. So remember that the 1140 transmitter consists of 1310 exciter, an 1110C power amplifier, and the 1124 power supply. So mostly I've been looking at the 1140 integration manual, system manual, I guess is the right term, that shows how all the bits and pieces connect up. But here I found a mention of the antenna coupler in the amplifier document itself. So let's zoom in and have a read of this. Anyway, somebody made these notes prior to my getting the manual. But the bottom line here is, listen to this. The coupler also uses a separate coupler ready line to indicate to the PA that it is tuned. The coupler start test is activated by the PA to start the byte, this built-in tests on the antenna coupler. And finally, the antenna coupler reports its bit results via timed pulses on the coupler test status. Now, why is all this interesting? This is all interesting because, as I showed in the last segment, these three lines mentioned here, are disconnected. They're not used. They're open. Those switches are open. So here's what I'm thinking. What I'm thinking is that 1130 transmitter that I've been using as the basis for the configuration of the 2602 status monitor is not appropriate for the 1140 transmitter. Clearly, this PA, this power amp, is expecting a coupler ready line, a start test line, and a test status line. And by the way, this is particularly interesting, I'd say. Here, let's see if I can do that better. Via timed pulses. Now, we all look at that, the status LED on the status monitor, the coupler status monitor, and we see that it produces a series of timed pulses. In our case, we're getting 3 pulses, space 4 pulses. Yeah, so this does make a lot of sense that there would be some sort of feedback, status feedback, from the coupler to the amplifier if the amplifier was capable of accepting the status. Now, clearly the 1130 transmitter was not, but according to this, I'm very hopeful. I'm thinking that the 1140 is maybe more advanced and can get some status back from the coupler. So I think the next step of what we're going to do is enable some more lines in the status monitor and see what happens there. Okay, so what we're going to do is I'm actually going to enable all these lines. I don't really see a downside because if the transmitter doesn't care about the line, it could ignore it. It just would ignore it. I don't see how it could really interfere with anything. So let's enable all of these switches here. 1, 2, 3, 4. 1, 2. Oops. 2, 3, 4. Now, one of these, I think it's this one or this one, has no connection, but it doesn't hurt to be connected. So they're all connected up. Let's just review again what we've done, looking at the circuit diagram, and then we'll test it. Okay, so here's the diagram again. We've now closed, this is the one that doesn't matter, S11. We've now closed all of these. And so let's just review which signals will now be able to pass between the transmitter and the coupler. Coupler's over here. There we go. There's a coupler. Let's review the signals. So the first one here, okay, bypass that we had before. Now coupler fault will go through. Over temperature fault will go through. Test will go through. Test status. Coupler ready. And fault override. So yeah, these will be very interesting. Let's give it all a test and let's see what happens. All right, so we're gonna try this again. We now have all the lines enabled, and let's see if anything different happens. Hit standby. All right, we'll go to operate. See here, normal operation, and let's do a tune. Okay, let's take a look at this. So, still have a fault, but let me, okay, and it shut off, but let's take a look at this. Let's see if you can see what I'm seeing here. Look at this is phenomenal. We now have a message, a specific message on the amplifier. It says, 5A14, runtime fault. 5A is the coupler, by the way. And look at the message, coupler low pressure. All right, so what does this all mean? So it means that that in fact we did need additional lines to come through. One line in particular, the test status line, with its blinking lights, now seems to be able to be translated. The sequence of blinks is able to be translated by the amplifier into an English message. Very interesting. Let's try it one more time. Well, let's see if I can get back to a place where we can see all of it. Okay, so I turn the amp off, go to standby, go to operate. I decided to turn some more light on in the shack. All right, so amp off, standby. Hopefully you can see here it says normal operation. Operate. And let's try tune. Okay. Still get the fault. And eventually it looks like it shuts down. And again, let's take a look at this. Coupler low pressure. Okay, so now I am pretty confident that in fact, first of all, I think we've got the configuration switches correct on the status monitor, number one. And number two, now I am confident that the error really is a low pressure error. And I mean, it makes a lot of sense. I was just confused because we were able to do a fully functioning test with the system using a non-Harris amplifier, and I'd figure if it was low pressure now, it would be low pressure. Would have been low pressure then, and why allow it to complete? I would have figured it would have faulted then. But anyway, so I think we have a low pressure issue, and let's see what we could do to correct it. But really, great progress so far. Okay, so I brought out of the garage my bicycle pump here, and it's just a hand pump. Press it down. And it is connected to the Schrader valve, if you can see it, on the coupler. And I've pumped it up to, I can't quite read it. What does that say? Looks like maybe, what does that say here? Let's see, 10.86, maybe about 7 pounds. Yeah, about 7 pounds. And so, let's give it a try. Let's power everything up. Again, we've got the open 2602 status monitor with literally almost everything now closed. And as I mentioned before. So let's turn this on. All right, let's walk over to the transmitter and turn that on. All right, we flip the switch. As you can see here, The exciter is still pulled out of the rack because I was messing around with switches. Alright, and actually we have a fault already. Let's see what this fault is here. Turn the light off. It says coupler low tune power. Oh, that's okay. We're not connected up yet. I don't know why that all is. So let's go into standby mode and operate mode. You can hear all the fans, and it's ready to be tuned. But we're not. Instead of tuning it from here, this button, which you would normally do when you're operating, let's tune it over from at where the coupler is. Okay, so we're going to initiate a coupler tuning cycle by hitting this key button. Well, retune is it's already in retune request mode, and then I'm going to hit this, and let's take a look at the power meter. All right, so, and for the first time, you can see the ready light. No fault, we've got a ready light. And I'm going to use this key here, which is connected over to the transmitter. And let's see. Yeah, there we go, about 750, 800 watts. And an SWR very low, very, very low. So that's great. And as you can see, it's working. Let's do another one. We'll go into tune request and then key, and we'll watch this again. Okay, and that's it. You can see. Now let's again use the CW key here. Beautiful, 700, 800 watts, very low SWR. Now we're going to do the same thing from the transmitter and take a look at how that looks. All right, first thing, let's change the frequency so it's got a good reason to try to retune. And we'll just change it to 12, 3, 4, 5, 6, 7. All right, so we're 12 megahertz. And as you can see, the tune light came on again. And we're going to hit tune, and it's going to do the same thing. And meanwhile, we're going to look at, this is the output going, this is the power going to the dummy load. Let's try it. All right, let's see, did it work? All right, now the tune light is out, but the ready light is on, which is good. We've got no errors, no faults, and looks like it's working well. Let's key it up again from the CW key. Okay, so we're back. We're going to key it with the CW key at 12.34 megahertz. Very nice. Looks like about 750 watts, about 700, 800 watts. All right, so that's it, and you can see the coupler ready light is on. It's wonderful, all because of about, I don't know, 7 or 8 pounds per square inch of what does that say? Can you read that? 6, 2, 4, 5, maybe 5. I think that's 5 pounds per square inch of air. Of course, this is supposed to get nitrogen. We'll worry about that later. All right, so the darn thing works. So it appears now that we've really solved all the remaining issues, and the system's now ready for installation. We'll find a place on the outside of the house to mount it, as it only have a 50 feet cable, probably not really far enough to run it under the ground like I have my other vertical, so but we'll see. So the other thing I'll mention is, since recording that last segment, which was about a day ago, I have seen that the air pressure started to decline. So there's clearly a leak in this, and actually I'm not very surprised, and the reason is because as I went to remove these 2 bolts to install the long wire adapter, I noticed they were very loose. And then I looked at some of the other bolts, and they were also, to tighten them, and they all needed tightening. So my guess is that I need to tighten this all down. I'm hoping I don't need to replace this rubber gasket. I'm hoping it's still good, because that would really be a pain in the neck. So that's good. And let me show you what's involved with that. Some people who work on car engines will see what I'm talking about, will recognize this. Okay, so here's another page from the manual of the antenna coupler here, the 2601, and it gives the details on how to remove the shock cover, which is the big old gray semi-circular, semi-cylindrical, I guess you can say, cover that we were looking at with the bolts. And anybody who is familiar with mechanical work on an engine, you'll notice this bolt pattern. And other than loosening it, this is also the bolt pattern you need to use to tighten it. And so you've got to do this bolt first. They're all numbered. Number 1, then you go to number 2, number 3, number 4, 5, 6, 7, 8. Where's 9? 9, 10, 11, 12. And this is the same sort of pattern you use when you're bolting down a cylinder head to an engine block. And the idea is to get to make sure that there's no, I don't know what the term is, malformation in this, and that it's smooth, and you want to basically tighten it from the inside out on both sides, inside to out and inside to out, to make sure that it's as taut and tight against the base as possible. Okay, well, it looks like we've come to the end of yet another project. We've got the antenna coupler wired up and working with the status monitor, and I can now also use the coupler and status monitor with any transmitter in the shack. It does not require any real wire integration. And so I want to thank you. This has been a long one. It's about 44 minutes, and I appreciate all your patience. And thanks again for taking this trip with me.